Hi, my name is Bill Hogan. I'll be walking through our recent work titled Abstractified Multi-Instance Learning for Biomedical Relation Extraction. The question we're asking is, how can we automatically extract fact triples from large amounts of raw biomedical text, such as PubMed? In this work, we use a distance supervision approach where we start with a knowledge graph of biomedical entities and raw text from PubMed. Then we make the assumption that any sentence that contains an entity pair that is linked in the knowledge graph expresses the relationship between those entities. This allows us to automatically generate labels. However, this assumption leads to very noisy labels since not all sentences will express a relationship. To address this issue, the current state-of-the-art models use multi-instance learning, which groups sentences into bags with the intuition that a group of sentences will more likely express a relationship than a single sentence. However, fact triples and their corresponding sentences suffer from a long-tail distribution. Over 50% of entity pairs are only supported by 1 to 2 sentences, and in such cases, we heavily rely on upsampling to fill bags of sentences, which diminishes the effectiveness of multi-instance learning. To address this issue, we developed a model that adds a layer of abstraction. We call it Abstractified Multi-Instance Learning. We abstract entities into their corresponding entity type and use the entity types to form bags of sentences. Using this method, we were able to reduce single sentence bags by half. Relationship embeddings were also improved with our model by conducting a suite of relationship embedding experiments, and we propose a few novel relationship representations that improve model performance in all metrics. Here we see an example of data flow in our model AML. We start with a bag of sentences, send it through BERT, get the encoded input sequence. We concatenate selected tokens to form the relationship embedding and send it through a linear layer, which predicts the corresponding relationship type. Looking at the performance, we see here that AML beats the current state-of-the-art in almost all metrics, and our novel relationship embedding type L here ends up improving again on top of our AML baseline. For more details, check out our paper, and thanks a lot.